All right, next function, we've got f of x equals the absolute value of x minus 1, that whole quantity, and that's on the domain of x is less than 1. And for this second part, we've got the square root of x subtracted by 2, and that's for x is greater than or equal to 0. So again, let's call the top one a and bottom one b. For function a, I've got a domain where x is less than 1. So I'm going to start at 1, go to 0, negative 1. And I can see here I'm going to have an open circle at 1. So when I plug these values in, 1 minus 1 is 0. Absolute value of 0 is 0. 0 minus 1 is negative 1. Absolute value of negative 1 is 1. Negative 1 minus 1 is negative 2. Absolute value of negative 2 is 2. Okay, so I'm going to just plot my points. 1 comma 0 is going to have an open circle here. 0 comma 1. Negative 1 comma 2. All right, so I can see this is the vertex actually of this absolute value function. Remember, if we have x minus 1, that means we've shifted it over 1 unit to the right. So my vertex is going to be at 1 comma 0. That's exactly there. So we're not going to have the other half of this symmetrical function, just the left half. All right, now we'll do function b. All right, really, I guess I should be using f of x for my second column, not a huge deal. Okay, so first value is 0. I could just write 1, 2, 3, but I know this is a root function, so if I plug in a number like 2, it's going to be irrational, so I'm just going to do 0, 1, and 4 to make my life a little easier. All right, so when x is 0, square root of 0 is 0. 0 minus 2 is negative 2. Plug 1 in, square root of 1 is 1. 1 minus 2 is negative 1. Plug 4 in, square root of 4 is 4. Sorry, square root of 4 is 2. 2 minus 2 is 0. So now I'm going to plug these points. It's inclusive at 0, so I'm going to make it a solid dot. All right, so 0, negative 2, 1, negative 1, and 4, comma 0. And that should be enough for me to get an idea of what that function is going to look like. So now I have to test, is it a function or not? So does it pass the vertical line test is really what they're asking. And we can see that right here, it fails the vertical line test, and actually fails it several times in this area here, because there are 2 y values for a single x value. Right, when x is equal to 0, it could either be negative 1 or negative 1, or I mean 1 or negative 2, so that doesn't make any sense. You can only have one output for each input. So we can say no. And we should have been able to see this really from the domain. X is less than 1 or x is greater than 0. We see there's an overlap here. So that should set you off also that this can't be a function. All right, so f of negative 4, 1, 2, 3, 4, that's equal to 1, 2, 3, 4, 5. F of 0, well, here's the issue, right? This is why it's actually kind of tricky that it's not a function, because f of 0 could be 1 or negative 2. So that's a tricky part. All right, f of 3. Well, I could look at the graph, but that, that's a very hard value to estimate. So I'm just going to plug it in to my function, and I'll get radical 3 minus 2. And I cannot simplify that, so that's just how I'm going to leave it. All right, next one, 2 linear functions. All right, so let's call them a and b. All right, for a, x is less than or equal to 3, so we'll start at 3 and start getting less and less. And that'll be a closed dot because it's inclusive. Here, x is greater than 3, so I'll start at 3, you get higher and higher, that'll be an open dot. All right, so this function, this top function, is always equal to negative 3. So no matter what my x is, my y will always be negative 3. So 3, negative 3 will be right here. 2, negative 3. And we can see it's just going to be a horizontal line. All right, not the best line. I could have made that a little bit better. See, it's a little bit above the grid there. All right, that's pretty good. All right, next, plug 3 in here. 2 times 3 is 6. 6 minus 5 is 1. 2 times 4 is 8. 8 minus 5 is 3. 2 times 5 is 10. 10 minus 5 is 5. 3, 1, 4, 3, 5, 5. Okay, is this a function? Yeah, it passes the vertical line test. Right here, there's an open dot, so it doesn't exist 2 different places at once. F of negative 4, that's just going to be equal to negative 3. F of 0, that's just equal to negative 3. And F of 3 is also just equal to negative 3. All of these numbers are within the domain of the first function, which is always equal to negative 3.